dear students. So in this session also I continue my previous topic, that is problem solving using principle of mathematical induction. Okay. So the problem is, prove by mathematical induction that 1 cube plus 2 cube plus 3 cube plus etc. plus n cube is equal to n square into n plus 1 the whole square divided by 4. So we have to prove this statement using the principle of mathematical induction. So what is the first step? So in that, first we have to take the given statement as P of n, right? Let P of n is equal to what? 1 cube plus 2 cube plus 3 cube plus etc. plus n cube is equal to what? N square into n plus 1 the whole square whole divided by 4. So first we have to take the given statement as P of n. So then step 1. What is step 1? So step 1 is prove that P of 1 is true. So prove that P of 1 is true. This is our first step. So for that, n is equal to what? 1. So when n is equal to 1, what is P of n becomes? If it consists n number of terms, it becomes 1 cube, 2 cube plus etc. plus n cube. If n is equal to 1, it consists only one term, that is 1 cube. That is LHS becomes 1 cube. 1 cube is nothing but what? 1 cube is 1. That is equal to 1. This is what? Our LHS. And come to the RHS, put n is equal to 1. This is our RHS. When n is equal to 1, so RHS is equal to what? N square means 1 square into n plus 1 the whole square. So n is equal to 1 plus 1 the whole square whole divided by what? 4. When you simplify this one, we will get 1 square is what? 1 into 1 plus 1 is 2. 2 square is 4 whole divided by what? 4. So 4 gets cancelled. So the remaining answer is 1. So LHS is equal to 1. RHS is also equal to 1. So therefore LHS is equal to what? Our RHS. Hence P of 1 is true. So our first step is completed. So first step is we have to show that P of 1 is true. So then what is the second step? Step 2. Step 2 is assume that P of k is true. This is our second step, right? We have to assume that the given statement is true for some k. That is, assume that P of k is true. So the result statement becomes what? 1 cube plus 2 cube plus 3 cube plus etc. plus n cube becomes what? K cube. That is equal to RHS becomes k square into k plus 1 the whole square whole divided by what? 4. This is, we are assuming that the given statement is true for some k. So this is our statement. This is our step 2. Then what is the step 3? Step 3 is prove that P of k plus 1 is true. This is our third step, right? So we assume that P of k is true. Now we have to show that P of k plus 1 must be true. That is, so P of k plus 1 means, what is the statement becomes? So 1 cube plus 2 cube plus 3 cube plus etc. plus k cube plus what? K plus 1 the whole cube. K plus 1th term. This is our k plus 1th term. That is equal to, RHS becomes, put k is equal to what? K plus 1. So k square becomes k plus 1 the whole square, right? So here we have k plus 1. So k plus 1 whole square is there. Put k is equal to what? K plus 1. K plus 1 plus 1 whole square. So k plus 1 is 2 whole square. So if we put k is equal to k plus 1, we get k plus 2 the whole square whole what? K square into k plus 1 the whole square divided by 4. So from 1 cube, 2 cube up to k cube, we have got k square into k plus 1 the whole square whole divided by 4. Right? So this is from step 2. Plus the remaining term is k plus 1 the whole cube. Understand? Now take the LCM. So 4 is the LCM. So k square k plus 1 whole square, right, as it is. So here we have plus. So 4 into this term. So it becomes 4 into k plus 1 the whole cube. Understand? In this step I will take the LCM. So in the next step, observe that in both the terms we have k plus 1 whole square is a common factor. So take k plus 1 whole square as a common factor. Okay. So what is the remaining term? K plus 1 whole square becomes common. So here we get only k square plus. So here we have 4 into k plus 1 the whole cube. So we take k plus 1 the whole square. Two term na common tagidvi. So we get remaining 1 we have. So 4 into k plus 1. Understand? So here we have k plus 1 whole cube. 3 terms is there. So k plus 1 whole square. Two term na we take it as common factor. So the remaining is k plus 1 whole divided by what? 4. Understand? So k plus 1 the whole square into k square plus multiply. 4 into k becomes 4k plus 4 ones are 4. So we have to multiply 4 by k and also for 1. So we get 4k plus 4 whole divided by what? 4. Okay. So next you have to factorize this term. So how to factorize? I will factorize here. So k square plus 4k plus 4, right? So multiply madidre we get 4, add madidre 4 barbeku. So what are the two terms? 2 and 2, right? 2 plus 2 is 4, 2 into 2 is 4. So this can be written as k square plus 2k plus 2k plus 4. So take here k as a common factor, it becomes k plus 2. Okay. Here also take 2 is the common factor, so it becomes k plus 2 2s are 4. So k plus 2 and also remaining is also k plus 2. So it becomes k plus 2 the whole square. This is the factorization of this one, k square plus 4k plus 4. So replace this term by k plus 2 the whole square. So k plus 1 the whole square into this means what? K plus 2 the whole square whole divided by what? 4. And this is our RHS. Right? So therefore P of k plus 1 is true. Right? So in the first step we prove that P of 1 is true. In the second step we assume that the given result is true for some k. So in the step 3 we prove that P of k plus 1 is also true. So all the 3 steps are completed. So finally write down from the principle of mathematical induction the given result is true for all natural numbers. So shall I write here? So you must write at the end. So therefore by the principle of what? Mathematical induction, the given result is true what? For all natural numbers. Understand? So from the principle of mathematical induction, if all the 3 steps are satisfied or completed, you must write at the end that by the principle of mathematical induction, the given result is true for all natural numbers. Understand? So this is for 1 cube plus 2 cube plus 3 cube. Shall we move on to the next one? Okay. Okay. So first we have to take the given statement as P of n, right? So let P of n is equal to what? 1 square plus 3 square plus 5 square plus etc. plus 2n minus 1 the whole square is equal to n into 2n minus 1 into 2n plus 1 whole divided by 3. So first take the given statement as P of n. So next step 1. What is step 1? Prove that P of 1 is true. We have to prove that P of 1 is true. That is n is equal to 1. So LHS becomes what? First term is 1 square. 1 square is nothing but 1. So LHS becomes 1. So what you RHS becomes, put n is equal to 1. So 1 into 2 into 1 is 2 minus 1. 2 into 1 is 2. Plus 1 whole divided by what? 3. So it is nothing but 1 into 2 minus 1 is 1 into 2 plus 1 is 3 whole divided by what? 3. 3 gets cancelled. 1 ones are 1. So LHS is equal to RHS, right? Because both are equal to 1. Therefore P of 1 is true. So in the first step we prove that P of 1 is true. What is the next step? Step 2. Step 2. Assume that P of K. Assume that P of K is true. So we have to assume that the given statement is true for some K. That is P of K. That is, what is the statement becomes? 1 square plus 3 square plus 5 square plus etc. plus 2k minus 1 the whole square is equal to k into 2k minus 1 into 2k plus 1 whole divided by what? 3. This is P of k. So when come to the step 3. Step 3 is prove that P of k plus 1 is true. Right? So the statement becomes 1 square plus 3 square plus 5 square plus etc. plus 2k minus 1 whole square plus we have to write the k plus 1th term. So ಇಲ್ಲಿ k put k is equal to k plus 1 ಅಂತ. So what is the last term? That is 2k minus 1 the whole square, right? Put k is equal to k plus 1. So 2 k means k plus 1 minus 1 the whole square, right? So 2 into k is 2k plus 2 ones are 2 minus 1 the whole square. Okay. So 2k plus 2 minus 1 is 2 minus 1 is 1 the whole square. So the next term is 2k plus 1 the whole square. 2k plus 1 the whole square. This is k plus 1th term. Next term. Okay. That is equal to RHS becomes, that is equal to, put here k is equal to k plus 1. So k plus 1 into, so 2k minus 1 ಅಂದರೆ 2 into k plus 1 minus 1, 2 into k 2k plus 2 ones are 2 minus 1. So 2k plus 1 ಆಗುತ್ತೆ. So 2k plus 1. So the next term is 2k plus 1 ಅಂತಾನೆ ಇದೆ. Here also put k as k plus 1. So 2 into k 2k plus 2 ones are 2 plus 1. So 2k plus 2 plus 1 is 3. Understand? So 2k plus 1 becomes 2k plus 3 whole divided by what? 3. So we have to prove this. This is k plus p of k plus 1. We have to show this. Okay. So for that consider the LHS. So consider what is our LHS? 1 square plus 3 square plus 5 square plus etc. plus 2k minus 1 the whole square and the last term is plus 1 square plus 3 square plus 5 square plus etc. plus 2k minus 1 the whole square is equal to what? This one. So k into 2k minus 1, 2k plus 1 whole divided by what? 3 plus what is the remaining term? 2k plus 1 the whole square. What is the next step? We have to take the LCM. So 3 is the LCM. So k into 2k minus 1, 2k plus 1 plus. So 3 into this term, that is 3 into 2k plus 1 the whole square. Understand? So next, in the next step, what is the common factor? Here also we have 2k plus 1. Here also we have 2k plus 1. So take 2k plus 1 as the common factor. So what is the remaining terms? 2k plus 1. This common tagdiddivi. Remaining is k into 2k minus 1, right? So plus here we have 3. 2k plus 1 whole square. Eradu term ittu. One term we take it as common factor. So we remaining is 2k plus 1 whole divided by what? 3. So simplify this one. 2k plus 1. So k into 2k is 2k square. Okay. Minus k into 1 is k plus 3 2s are 6 into k is 6k plus 3 1s are 3 whole divided by what? 3. So 2k plus 1 into 2k square. So minus k plus 6k becomes what? Plus 5k. 6 minus 1 is 5 plus what? 3 whole divided by 3. So in the last step we have to factorize this one, right? So how to factorize? So shall I write here? So factorize 2k square plus 5k plus 3. So 2 3s are 6. Multiply ಮಾಡಿದ್ರೆ 6 ಬರಬೇಕು. If you add, it becomes 5. So 2k square plus 5k can be written as 2k plus 3k. Can we write like this? Yeah. 2 plus 3 is 5k. 2 3s are what? 6. So plus 3. So group the terms. So here take 2k as the common factor. So it becomes k plus 1. Plus here take 3 is the common factor. So k plus 1 ಆಗುತ್ತೆ. So k plus 1, k plus 1. And the remaining is 2k plus 3. Right? So this is 2k plus 3. So factorization of this one, k plus 1 into 2k plus 3. So 2k plus 1 into, so this means what? K plus 1 into 2k plus 3 whole divided by 3. This is our RHS, right? This is our RHS. So therefore P of k plus 1 is true. Okay. So all the 3 steps are completed. So therefore by the principle of mathematical induction, the given result is true for all natural numbers. You must write at the end. You must write this sentence at the end of this problem. Understand? So this is the problem solving using mathematical induction. I will continue this topic in my next session.